Scott, thank you for joining us. The floor is yours.
All right, thank you very much. And thank you, everyone, for joining this particular, the way forward, the practical guide to achieving IT/OT convergence. Really appreciate it. And thank you very much for joining. Now, before we get going and having this conversation, I had a couple of thoughts in mind. One, it's 2022 right around the corner, and that's really important because IIoT world does a great job at educating, does a great job at collaborating, as well as does a great job at promoting innovation through that conversation. The thing that I want to challenge everybody on this particular session is let's take 2022 and let's be more action oriented. It's always great to be able to say, yeah, I'm educating. Yeah, I'm collaborating. Yeah, I'm innovating. But if we don't take action, well, we're not moving forward. Also, some rules. Let's talk a little bit about rules that we need to abide by. One, you need to be engaged. Everybody that's on this particular, in this session, you need to be engaged. You need to be asking questions and peppering this panel with as challenging questions as you possibly can. Now, one of the things that I do not guarantee is that I'll pronounce your name correctly. I will try my best, but it's not out of disrespect. I will probably end up mispronouncing your name, but disregard. It's the question that we want to make sure that this panel receives. And as well as we want to be able to challenge them. So do not, it is important that we all do our part to be able to challenge this great panel, to be able to talk a little bit about that IT/OT convergence. Now, the incentive. The incentive is if you got relevant questions, then there's a VIP opportunity to be able to join the IIoT world community. And that is going to be the responsibility of Lucian, and he will let you know about that. And then finally, at the end, we're going to have a drawing, the 5 winners, to be able to get free books. I think it's Rebecca Morgan, and they're going to be a drawing on that at the end of this particular session. So hang in there, do not go away. And Lucian is going to spin the wheel and identify the individuals that get that free book. I hope I win. No, I'm already reading a bunch of books. All right, again, so we've got 2 individuals. We're going to proceed forward. The first gentleman is named Shamik, and the other one is John. Now, Shamik, give us a little background on who you are.
Thanks, Scott. Yeah, I'm Shamik Mehta. I'm Director of Industry Solutions Marketing at Hitachi Vantara. Been with the company for about 4.5 years. Quickly before that, I've spent most of my career in product marketing, solutions marketing for software products in the field of IoT, data management, and renewable energy before that for about 6.5 years in a wind and solar company, and then manufacturing of semiconductor equipment before that, and a semiconductor maker, all here in the Bay Area. Happy to be associated with all of you today. Looking forward to this engagement and to your questions.
All right, John, do not let us down. That was a great intro by Shamik. Give us a little background, John.
Okay, yeah. So like Shamik, I've been with Hitachi for quite a while, 8 years, focused primarily on IoT solution architecture. I lead a team globally that does solution architecture for primarily manufacturing, but industrials in general. We've done some oil and gas, mining, transportation, a number of other things. But my background is software, so I'm a little bit more on the technical solution architecture side. But I've done a lot of work, process work in manufacturing as well over the years. So thanks.
All right, well done. All right, Shamik, for everybody out there, including me, because I am not the sharpest tool in the shed or the sharpest knife in the drawer, give us a little sort of primer on what an IT and OT conversion, what does that mean?
Sure. Yeah, IT, information technology, OT, operational technology. And there's a lot of talk about the need to merge the 2 departments. And, it's IT, OT conversion doesn't mean that you're taking the 2 departments and merging them into one business unit. It's really taking the data from those organizations and merging those and being able to merge them so that you understand what's happening on either side of the fence on those both departments.
Now, what's the benefit? What are we talking about here? Why? The old way of thinking is that you have 2 separate entities, really, IT, OT. John, what What is OT? Sort of define what that OT is. I got
Well,
IT.
Yeah, okay, so that's a good one. So operational technology, when we talk about it, we talk about pretty much the technology that's on the shop floor, and getting data out of that and integrating it with the IT data in the back office. So a good example of that is sensors, PLC data, SCADA historians, and then on the IT side, we integrate with MES, ERP systems, CMMS, ticketing systems, maintenance systems, quality systems. So right now, OT is typically very siloed. And so the idea is to take that data from those devices, blend it with the back office IT data for higher level insights and analytics.
All right.
Good one.
Why, Shamik? Why is this important? Why is this transition? Why do we need to proceed this forward in that way? Why is that important?
When it comes to the world of manufacturing, people sometimes may not realize it, but we've been a manufacturer ourselves for over 110 years. So we make everything from nuclear power plant equipment to the SCADA systems for utilities to CNC machines and robots and rovers that can go underwater or inside sewer lines with video cameras, and all the software that is used to understand what all those equipment has been measuring and sending over. So we ourselves are a very large manufacturer. In fact, let me share with you a quick brief for those who are not very familiar with Hitachi. We are the 8th largest tech company in the world, and we are the 24th largest manufacturer in the world. We are a group of 800 companies around the world, 140,000 people that work just in manufacturing. This is not our full strength. We are over 300,000 employees worldwide, but over 140,000 of them are manufacturing employees. And we started off doing this in 1910 in Japan, and we still are. So we have been making this equipment, gas turbines, wind turbines, battery storage, CNC machines and robots, and other shop floor equipment, including automotive parts. And we've been instrumenting them with IoT sensors, collecting data from them, both to improve our own parts, but also to understand how the parts are working in our end customer systems. So we've been understanding and reading what our machines have been telling us for 60 years and more. So we understand this. We can understand how to figure out what the machines are telling us, create the models using machine learning to understand what that means in terms of how the machines are performing right now or may perform X times into the future. And we can blend that with management of the data, whether you put that data on premise on a unified compute server or in a storage device, or you want to put it in the cloud, it doesn't matter. We do all of that. So we have the domain knowledge and we have that IT knowledge as well.
All right. Again, I want to make sure that we impart and impress upon everybody that's on this particular session to ask your questions, to pepper this panel with questions that are really important. And I'm going to continue to start. I'm going to be doing that until somebody asks a question out there. And I'm looking, still nothing yet. Make it happen, Captain. All right. This is to John. What is the primary drivers for integrating IT/OT data? Is it uptime of machinery? Is it maximizing yield, minimizing scrap? Give us a little guidance on that.
Well, it's kind of all of the above. But one of the things we found, especially since COVID, is the overarching driver is the need to increase production without capital outlay for new equipment and new lines. And so, but once we hear that as a goal, then we dig a little bit deeper and find out that maybe their scrap rate is too high, or their scrap rework rate, or maybe they have certain machines that are critical that have too much downtime. So it's a machine uptime issue. We have one customer that has just crazy amounts of work in progress inventory in the middle of multiple steps in their process. So theirs is more of a process oriented problem. So the main driver is increasing throughput and improving that top line, getting more product out the door. We've got one other customer, a really good example of this, especially right now. Their backlog is half of their annual revenue. And so if they can get 10% more products out the door, it improves both their top and their bottom line. So it's a myriad of things, and we go in and talk to manufacturers, try to figure out what their biggest pain points are to get to the point of increased production.
Yes, Scott, I can give you an example. I can
Yeah,
add to
please.
that. You are employing all of these technologies and buzzwords, IoT, IT, OT, convergence, AI, ML. But at the end of the day, it's all meant for businesses to either make money or save money. And if you're not doing either one of those two, then none of us should be here right now. But that's all we do. And the focus should be on whether you can help a customer achieve that. So when you talk about saving on rework or saving on scrap, consider the railway industry. Railways have got this very fixed maintenance schedules, for example, for changing the wheel sets on the trains. So every 6 years or so, all the wheels, that typically there are 8 wheel sets under a car of a train. You got to take that coach, send it to the maintenance yard, and you got to literally raise the entire car and separate out 8 wheel sets. And you got to replace them if it's been 6 years or right around that. There is no real way to analyze whether those wheel sets need to be replaced or how many miles they've ridden. Different cars often drive different distances. So the wear and tear and the temperature conditions and the grades of the drywall, everything is different for many of these cars because they don't all stay tied to the same train. Replacing them every 6 years is often not necessary, and most times is not necessary. And replacing each set is about $40,000 to $120,000 worth of cost in just the replacement alone, the labor part of it. The actual cost of the wheel sets is completely different. So one way we could figure out whether those things needed to be maintained is to put wayside laser sensors to both listen and look and take critical dimensions of the wheel sets and brake pads as the train rides through at frequencies and at speeds that human beings cannot, and use that to build a model to analyze what a good wheel set looks like and what a slightly deteriorated wheel set looks like, and change from a schedule-based maintenance of every 4 years or 6 years to one that is based on conditions.
See, it's a smarter way of sweating that asset and changing it out at the right time, right? Getting greater value out of that asset. Excellent, excellent. Now, here's a great question, and I have to agree with this one. And this is from Jahur. I'm going to again, sorry, it's not disrespectful, but anyway, who owns the OT versus IT? Why it needs to converge? Why it needs to converge? So who owns it, and why does it need to converge? John.
Okay, yeah, I can take that one. So who owns it? What we find is obviously there are IT departments that run all the back office systems and so on. And typically there's an operational group with like control systems engineers that are really and maintenance people that are managing the machines themselves. And as such, you have this gap in terms of shop floor networks. So what needs to happen is those control systems engineers need to get together with the IT people to bring it together. Now, as far as why it needs to converge, I'll give an example. We've seen this a number of times. We need to know the context of what a machine is doing at a time we collect telemetry from it. So we have one manufacturer we're working with that wants to do prognostics models, machine learning models to predict degradation of a particular machine, but that machine has different telemetry depending on the part type that's going through it. So if you have a high mix or even a medium mix, you want to maintain the context. The only way you can get that context is from execution systems or planning systems. So you know what part is being produced at a given time, and it provides the context to do the analytics around that.
All
That's
right.
one example.
Yeah. Speaking of which, now, Shamik, do we have a video that sort of gives us a little sort of a real case example of some of this OT-IT convergence? Do you have anything on?
I do. In fact,
Make it happen, Captain.
I do. In fact, what better way to do it than to ask John here to do an actual demo of what happens when you start combining data from your IT sources and from your OT sources. So if you give me a second, I'm going to queue up a little video. Let's take a look at what happens when that does. It's not little, I mean, it's a few minutes long, but take a look, because we often hear talk about people, including people like us sometimes, who speak a lot about the benefits of IT-OT convergence without examples, right? So, but what better way than to actually take a look at it? So give me a second while I stop the share of one and start the share on another.
Remember, everybody that's on this particular session, please ask questions of this great panel and make sure that you challenge them in every way you possibly can.
Can you see the demonstration screen of Lumada Manufacturing Insights?
No, what we do see is the presentation, the last presentation that you provided.
All right, then I'm going to have to share my entire desktop. And then you should be able to see QuickTime.
Yep.
All right, here we go.
Hello, my name is John Berniger, and I'm the Director of Solution Architecture for Hitachi. I lead customer solution architecture and design, as well as delivering and deployment of our industrial IoT platform and solutions globally. I'm going to be demonstrating our Lumada Manufacturing Insights platform, but before I start, just a few words of high-level overview. So Lumada Manufacturing Insights is an analytics and visualization platform that enables industrial customers, especially manufacturers, but others, to gain visibility into their operations, optimizing things like maintenance activities, reducing unplanned or reactive downtime, optimizing quality KPIs, so maximizing first pass yield, minimizing rework, things like that, and then monitoring of production process metrics. So
I'm going to have to interrupt, John. We're receiving some feedback that's saying no video.
Bottlenecks in the production process.
Sorry, what was that?
Oh, so that is the video. What we're hearing is John and the video. So individuals that are on the chat saying there's no video, apparently that's the video.
We don't want to leave anything to Murphy's Law. We don't want to take a chance of doing a live demo, so we recorded this just before today, just to make sure that we don't have a flaw.
Very good. Well, there you go. There's the answer. It is the video.
I hope that's okay.
Good deal. Continue.
All right. Excellent.
This system can be deployed fully on-premise in a customer data center or in a hybrid cloud model, and we've deployed in Microsoft Azure, AWS, and Google Cloud so far. And lastly, some of our customers prefer a more SaaS deployment model. So we also have the ability to deploy and manage manufacturing insights using Lumada Solution Hub. So we have a number of different ways to deploy it. Okay, so to start with, I'm going to walk through our administrative interface for Lumada Manufacturing Insights, highlighting the digital twinning capabilities of assets, production processes, and product types. For assets, we're showing a hierarchical representation of an industrial enterprise. In this case, is a fictitious company called Solution Industries with a set of 5 plants. We're going to drill into the Durham plant. The Durham plant is patterned after one of our actual Lumada customers that's a tractor manufacturer. So they have a machining line, a cabin line, and a final assembly line. We're going to focus on the machining line because this is a real machining line in Durham, New Hampshire, and we collected data from some of these machines. So at each level of the hierarchy, we see a set of metadata associated with that level of the hierarchy. So I'm going to look at the DMG mooring milling machine. So we have things like make and model. We have alert thresholds and things like that. But then within that machine, and based on the APIs and the payloads of the ingested data from that machine, we can gather sensor information. So if we look at some of the metadata for this particular sensor, this is spindle speed, We have the ability to map the device ID from the payload from the machine into its digital twin in our database. Enable KPI monitoring means that it's a time series piece of data. KPI label, human readable label, round-off factors, precision, and so on. It's important to note that you can always add more properties based on the payloads or APIs for those machines. And that can enhance both the analytics and visualization of the data. The one other thing that I want to say about the asset hierarchy is we're not demonstrating it here, but we also have the ability to create virtual sensors. So we can create time series data that's either a mathematical or statistical aggregation of multiple sensors for a machine. We also can twin products primarily for quality, and then processes, so process flows and subflows and so on. So jumping over to the dashboards, the whole purpose of this is to give different people at different levels of the organization, so different personas, different views into their operations so they can optimize. So in this the highest level view of Solution Industries is if I'm the Chief Operating Officer of Solution Industries and I log in the morning, this is what I see. I want to look at the OEE rolled up across all the equipment lines and factories in my operation, but I also want to be able to zoom in on particular factories that are having issues. So the Durham factory has an OEE of 51.1%, so we're going to drill into that. So once we drill into the Durham factory, so this if I'm the plant manager for this Durham factory, this is what I see when I log in the morning. So you see the three different lines: the machining line, cabin line, and final assembly line. You see the OEE rolled up across all equipment on those lines, and then you see the OEE for the machining line is 51.2. So that's pretty low. Up above, we also see this red bubble with 277 in it. So the number indicates the number of currently open alerts on all equipment on that line. And the color of the bubble indicates that the highest severity open alert is critical. So let's take a look at that line, see what's going on. So this is the line view. Again, we show OEE across all equipment on the line. We're also showing line health. KPI health is an indication of what percentage of time over a specified duration, in this case a month, that we were free of threshold crossings on sensor alarms. Anomaly health, we have built in, we have machine learning based anomaly detection that can identify when we have anomalies in a machine, even though no one sensor crossed the threshold. So it's a combination of sensors. So think of it as a virtual sensor. So 99.7% of the time on this line over the last month, we have been free of anomalies. So in the lower left, we see a picture of the line. In the lower right, we can actually drill in and look at one of the alerts. So this is a spindle current threshold crossing. So this looks like it's about a minute and a half duration that it crossed the threshold. But we see a little bit of before and after telemetry, so you can look at trends. And we have normal alert lifecycle capabilities like resolving and acknowledging alerts. We can also take a look at anomalies. And I'll go into a little bit more detail on anomaly detection, but basically what we're doing is we're calculating a virtual sensor that's called the anomaly index, and it's a combination of all the sensors on this device. And so and then we're prioritizing what the contributing factors are. So it looks like feed rate, coolant temperature, and spindle speed led to this anomaly. And you can identify in this case it's feed rate, in some cases it's spindle speed. And so this gives a maintenance supervisor or maintenance tech more information on what's actually going on that machine. But they can also look at this data and say, this really is not worthy of raising anything, so I'm just going to flag it as a false anomaly. And at the point the algorithm gets retrained, then it will get better and better based on false anomalies. We can look at the health of the individual machines across the line. We can look at the OEE of the individual machines. And we can also look at cycle time, which is really simple. It's planned versus actual takt time or cycle time for a given machine. So it looks like we're having a number of problems, both with cycle time and with alerts on the DMG mooring milling machine. So let's drill into there. We see the near real-time asset KPIs as the data is coming in. We have a Pareto analysis of downtime reason. In this case, spindle current is the biggest source of downtime for that machine. We have OEE, and then we can look at different parameters. So like coolant temperature is the only one that we've configured both an upper and lower critical threshold. The orange line is a mean over this period of time, and you can specify over different periods of time. We also have the ability, we don't have data in here now, but we can import maintenance history and correlate maintenance history with faults on the machine, things like that to help with condition-based maintenance. We can also look at a view of asset analytics, and I'm going to drill in here to one particular shift. So we can look at multiple KPIs on one screen. So here is where we see the spindle current threshold crossings. But we can also, this is always kind of interesting, correlating spindle current, spindle speed. There's a fairly good correlation there. Coolant temperature. So a maintenance tech can take a look at all of this data in one pane of glass and figure out what's going on. And then in addition, we've got the anomaly index that I mentioned before. So it's time series aggregation of the combination of sensors. And so this is where we saw one of the anomalies. In this case, again, it's feed rate. I'm going to flag that as a false anomaly. We also have the ability to flag undetected anomalies. So basically, false positives and false negatives can be used in the retraining of this algorithm. If we go over to process analytics, we're going to drill into one particular process on this tractor line. And I'm going to have to go back a little ways to find some data. Okay, so what this is doing is this is taking a look at the lead time across all three lines and subflows in the lines. And what we see here is each of these dots corresponds to one work in progress part. In this case, it's a tractor. So I want to drill in and take a look at what's going on with this particular one. So here we can see that there's all of a sudden the total lead time is blipped up. So we've got the machining line, the cabin line, the final assembly line. It looks like the problem is in the cabin line that's leading to delays, lead time delays. And we can actually look at where the delays are in that. So we can zoom in on a particular point in time. And we see delays on the machining line and the cabin line. Final assembly line, there are no delays, but we see the inherent delay because it's dependent on this delay in the cabin line. We can also look at the material arrival at stations on those lines and alerts that are happening on those lines. So in this case, it was a windshield mounting problem in that cabin line. And then we can look at also the operators on those lines. So really the idea of this piece of it is 4M root cause analysis for production process delays. Finally, we're going to go up to, let me drill back into the Durham factory. Let's look at the machining line. We're going to look at quality. So the quality dashboard allows you to take a look at quality trends over a set period of time. So in this case, a month, for particular product types, for defects within those product types. We can also do a Pareto analysis by defect across different product types. And what this does is this allows the drill down to what are the biggest issues with quality. We had one auto parts manufacturer customer that this is the main thing they wanted because they have very short takt time and very high quality requirements. So they wanted to do trending and Pareto analysis. We can also do quality by process. So for a given product, we can identify 4 different stations where which station is providing the biggest quality bottleneck. So in other words, the highest failure rate. This can be implemented to the extent that there is testing in the middle of the line. And then we also do quality forecasting. So we build root cause analysis models for defects. So we can identify whether it's the root cause might be an operator error. It could be raw material quality, or it could be something that went wrong with one of the machines on that line. So we build that root cause model, and then we can use that model to say when this, and this condition happened, you've got a 45 to 60% likelihood that you're going to have a lower pass rate. So anyway, that is a very quick overview of our machine production process and quality analytics within Manufacturing Insights. And I thank you for your time.
All right, Shamik, if you can, stop sharing your screen. We've got a number of questions that we need to begin peppering you guys with, okay? Sure. One is an interesting question, and I have to, it's provocative. This comes from Mark. I'm not even gonna try the last name. Mark, isn't all this IT, OT convergent talk just the latest version of MES and middleware, Shamik?
Yes and no, because I do not believe the MES systems were as closely integrated or worried about the IT portion of the data or external data. And by external data, I mean third-party data that the company may not even have in their possession, but may need to rent or may need to borrow or buy. Consider an energy plant, somebody that's creating and buying sources of energy, burning their own fuel, or importing it from other regions and then selling it on the market, right? For them, they need to also understand spot pricing in the energy markets. They need to understand weather trends. They need to know supply and demand and what the long-term and near-term weather is going to do and what does that mean for different sources of energy. That data is not something that they own, but they can get it from the NOAA. They can get wind speed data from anemometers. They can get it from other publicly available free as well as private data sources. All of that data needs to be visualized, captured, cataloged, ingested, translated, reformatted, even though it's for a temporary purpose. I mean, it's temporary over and over again, so it's permanent. But the traditional CMMS and MES systems did not have to deal with that. So we're talking now about a new revenue stream. We're talking about ways for organizations to get mature enough to be able to outsmart their competition and move beyond. So go from what's now to what's next.
All right, Jeannie, there was a question that she was provided prior to the video, and I want to just be able to address that video, and hopefully, Mark, that sort of addressed your MES and middleware question. If not ask another one, and we can ask for greater clarification. Jenny, here it is. It would be good to see the hierarchy. John, this comes to you just because you went through that video. It would be good to see the hierarchy of needs for connecting factory and how you can start and build on the use case for maximum value. Okay. It's my experience, if you start with some foundational area, you can build more quickly on each following use case applications. Do you know anywhere where we can find this kind of information or chart? It's a mouthful, but you can handle it, John. Dazzle us.
I think so. Powers of retention. So yeah, so we have a lot of content, and that is exactly what we do when we do deployments with manufacturers. Is sometimes they want to boil the ocean, and what we do is we go in and we say, okay, what are your, let's just say 10 to 15 biggest use cases, biggest pain points, and what do we, how do we prioritize those in terms of implementation feasibility and business value? Those are the two axes we look at. And then we come down to a small set, and then we say, okay, you've got to walk before you can run. Is your shop floor connected? Are you already ingesting some level of data that's going to support these analytics use cases? And so as an example, we've got one auto parts customer right now that we're just deploying OEE. They just want to be able to monitor their machines and do OEE for a small subset of machines on their floor. So they can scale out by adding machines to their asset hierarchy, but they can also scale up by adding use cases on top of that infrastructure. So as an example, the next thing we're doing with them is machine condition monitoring, which is doing more machine learning based prognostics and predicting degradation of the machines. So it's really, you've got to walk before you can run. You start small, scale out and scale up, but you have to have that base platform to start with.
So to really answer, yes, I can reach out to John and he can provide me with some information and charts.
It was a long-winded response, but yeah.
But is that it? Because I can reach out to you and you can provide that guidance?
We have that in
there you
space.
go. There you go. All right, this is from Doug. How important is having a unified namespace for OT data source? Shamik.
How important is it to have a unified namespace for an OT data source?
Yeah, that's the question.
Okay.
And you need to use your decoder ring if you're having troubles with that one, because that's the question.
Honestly, I'm having a little bit of trouble for it, but a unified namespace. I'm going to assume that this question means that do we need like a data warehouse or a data lake to be able to put all that data together and put it under one namespace, if I understand that level of software terminology. But you could make data warehouses as yet another source from which you can ingest analytics from. So for us, whether it's a cloud data warehouse like a Snowflake, or whether it's just a data lake anywhere else, or whether you wanted us to create a data lake using Hadoop, we have all of those are native to our technology. So by default, we can put things in a data lake and a single name source, or we could create that into a very customizable data warehouse, which is a slightly better, more refined model for a data lake. But apart from that, I think if the question needs any further clarification, please have the questioner reach out to me, either on LinkedIn or over here. You can share my email address and I can happily research that further and get back to them.
Okay, Doug, that is if we didn't answer it right, there it is. There's your call to action. John, this is going to be going to you. For a company that's outcrossing IT. I don't know what that means. If you know what it means, that's great. Outcrossing IT. Is it possible to still integrate IT OT? If so, what would be the bottlenecks and or downsides? Does that make sense?
It might be outsourcing.
Yeah.
They outsource their IT.
Yeah.
Yeah. Right.
Yeah.
Probably outsourcing.
Yeah, it is. Can you answer that, John? Do you understand?
Yeah. Given that it's outsourcing. So outsourcing can take multiple forms. So the IT could be outsourced to somebody that performs a managed service in a cloud or something along those lines. But the challenge is always going to be getting data into the IT infrastructure, bridging the shop floor network with the back office network, whatever form that takes. And if you're outsourcing your IT, it becomes a little bit trickier. But the thing is there are ways that we can integrate the OT data with the IT data, for instance, in a managed services cloud.
Right.
So
we already have like over 100 different connectors. So if that outsourced IT data is probably lying in somebody's ERP system somewhere, right? It's either in Oracle or an SAP, all of those and many more, we already have pre-built connectors for. So as long as we have the API available and there's a port definition available, we could ingest the data from the IT data, merge it with the historian or the SCADA data from the OT side, and we could still perform the analytics on it.
Well, and the one other thing that I would say is there's some tools out there that we're starting to see a lot more and use a lot more, things like Kepware, things like Ignition, for bridging some of those gaps. Like we've got one customer that's actually, they already have Ignition, so they're just sending us data in our managed services cloud. So there are lots of ways to slice that one, but it is a little bit more challenging if it's outsourced.
Short answer is yes. Long answer is it can be done.
Yep.
No, you got it was much longer than that. If that was the case, this is going to you, Shamik from Raphael. How do these systems integrate with the machines to get the sensor data and with ERPs to get, for example, maintenance history?
Most people will have settled on some sort of a centralized ERP system within their organizations. You can either have an SAP-based, most people will have either an SAP-based or an Oracle-based master database inside their companies. And we call that typically the IT base load of data. Merging that with another data source typically means that you need to have a connector and a way to format and reformat that data. So your IT data in, let's say, your HR data or customer billing data would be pretty much in a standard Excel type of a format. Whereas your OT or your sensor data that's coming from some of your machines is going to be timestamp data because it's coming in every few milliseconds or every few seconds. Not all of it is important, but you have it organized in a certain way. The database from which that comes from a historian is not of the same format as your Excel file. So it needs to be reformatted or reconfigured to match your schema. Your schema is basically your business rules. Not all fields of a customer's or a customer order or your customer information needs to be preserved in a certain manner. Some fields are important, some are not. So massaging all of that or changing all of that is what we call cataloging and integrating the data. So the schema matching, the extract, transform, load that needs to happen to get the IT data and OT data to match so that it makes business rules to you is something that we have been doing for years. We bought a company called Pentaho like 9 years ago. That was a leader in this cloud. It still is in this area. And that's what it does. It manages connectors, connects to different databases, including time series database locations for sensor data, and converts it into the format that you require, all in a graphical manner. So there's no coding involved. There's no SQL query writing. There is no going out and writing your own scripts for it either. You
so
can.
Shamik, a good example of that is one that we're doing right now with a manufacturer. We've got bidirectional integration with their CMMS. So we're pulling maintenance history using some of these tools, but we're also generating work requests, based on anomalies and alerts and things like that. So we have more than just the IT OT tools. We have a lot of data mapping and data manipulation, data integration tools as well.
Yes.
From DB, this is coming to you, John. From your experience, what are the challenges in achieving IT/OT? Best practice to overcome these challenges. What are the challenges? There's always some roadblocks. It's definitely not skipping and all that good stuff. What are the challenges?
No. Well, first of all, the back to the original question about ownership, the owners are different of the operational technology and the IT. And I don't know if it's everybody else's experiences, but in many cases, because they don't speak the same language, there's a lot of friction. And the thing is the operations people want outcomes. They want to optimize their operations, and that's all they care about. They don't care about the how of how it gets implemented, and in many cases, IT makes decisions without them. So I would say that is one of the biggest obstacles. There's some technical obstacles around integrating shop floor data with enterprise data, things like firewalls, because you can't. You can only have certain ports open because you don't want to. You don't want to have viruses or any malware enter your shop floor network, because that'll impact production. So the technical as well as the political are probably the two biggest challenges.
Yeah, I would second that. I have another example where I faced this challenge where we were working with a European energy giant that was in the process of sourcing and creating their own energy and selling it to tens of millions of customers in Western Europe. And their energy generation department and the energy trading department are not allowed by law to speak to each other. They can talk to each other, but they cannot exchange information to each other. So the generation plan that you have for where are you going to source which energy from and what fossil fuel are you going to burn, and for what's a plan is for the next few days or for the next 15 minutes, because energy is traded up to 15-minute blocks sometimes, their information had to be preserved in an Excel file and had to be very carefully shared, or could not be shared at all with certain parts of the trading desk, because the trading desk people were the ones who were making the deals on energy buys, and they're not allowed to speak to each other. So the generation people are the OT people, the energy trading people and the finance folks, 150 people working around the clock, if you believe it or not, are the IT departments, and they're not allowed to speak until we figured out a solution that automatically recatalogs, and reformats the data so that there is no regulation problem with knowing either the persons associated with the generation plans or the other operational or financial disclosures to go back and forth. And we could automate that. With data cataloging, we can automate that. And we were able to overcome it, but it took us a long time to get to that stretch, over a year.
All right, because I want to be able to try to say this name, and I think she brings up a good point, and I think it's in line with how do we proceed forward with this IT/OT convergence. Bellevue Dunn. Jeannie, I know I butchered it, but it's a cool looking name. Are companies continuing to put in chief digital officers to drive complete IT/OT convergence and assist the CIO and the business to build operational and business models around the convergence?
Yes.
Is this accelerating the business imperative? Excellent question. I agree. Who wants to take that?
I'll take it because it just happened. I just faced it a month ago, and then John, you can join in if you like. Yeah, we're working with an energy utility in Texas, and they had a reorg, and they shared with us their details, and they now have a chief digital officer and a VP of innovation, both titles that did not exist in an energy utility until recently. And both of those departments in the same department, the VP of innovation and the chief digital officer, have put out this 4-year roadmap, which talks about centralizing data around their core ERP system. And everything else is auxiliary to that. So integrating data from EV chargers and smart energy meters or solar PV rooftops and inverters is secondary and must work with the existing ERP system that they have. Otherwise, it will not be considered. So the approach for working or maximizing or applying IoT or analytics all should work within their existing business parameters. So definitely a trend I've seen.
Just to add to that, in manufacturing, we see that a lot of these initiatives can't be successful without a chief digital officer, transformation officer, innovation person, and so what's interesting is sometimes those people come from operations, sometimes they come from IT, but they know they have to bridge that gap. But they're key to those political divides between IT and operations. The other thing that's interesting that we're seeing is the groups that these people are forming are mostly coming from IT, but like an example, one manufacturer we're working with, one of the key guys in that group, the leader of that group, has been a welder on the shop floor for the last 30 years. So he comes from an operations background into an IT group that's doing the innovation stuff. So we're seeing a shift towards breaking down those barriers.
That's fantastic.
All right, here's Alan. He's got a sort of a two-parter. I'm going to start with the first one, and it's going to, I'm going to say, John, what has been some negative feedback offered by shop floor operators?
Probably the biggest negative feedback is in some cases, they have to change their process. And it may be people that have been doing it for the last 35 years. They don't want to take additional steps to document anything. So an example is automating data entry, building them a form rather than a paper form that they just write stuff down on. Getting them retrained to use that has been one of the biggest sources of resistance. The other thing is, and it's more subtle, is sometimes they think that what you're doing is helping the management to monitor what they're doing, and so there's a little bit of resistance. It's once again, it's a political resistance, but there's this fear that with some of these technologies, we're going to uncover things that certain operators are doing. We've actually seen that, and we've actually helped try to bridge that gap. But this is why you need a chief digital officer. You need somebody driving the transformation across both organizations.
Here's number two of that particular question. Do you have a case study where an implementation succeeded at one SME and failed at another, needing a similar solution? Do you have a case study of that? I don't know. Shamik.
Okay, good one.
They all succeed, right?
We don't fail.
No, that's no, that's not true. That's not true. But similar stories have failed in different organizations. Yes. So in manufacturing, we've seen some locations adopt like a digital Gamba board more readily than others. And I think it had to do with the ability for the shifts to congregate, to be able to share the notes instead of, when shift changes happen, operators will often talk about what settings they used that actually worked in one location versus another location where it's not exactly the same. In order to be able to share those, people are moving to digital Gamba boards, right? Where you do the analysis, instead of writing it down on Post-its on a giant wall, you have it recorded on a giant touchscreen, which also integrates data from other locations, all of that. We saw that work sporadically sometimes. And we do not know whether that was a cultural issue or whether that was a record-keeping issue or what it was. But I wouldn't say that one size fits all, and what works for one location or one line works for other lines.
Well,
all right, we're going to, go ahead there, John. I'm sorry.
I just had a quick one. So this is near and dear to my heart because even within a single enterprise, you may have multiple plants that are semi-autonomous and they have different drivers. So it's vitally important that we don't just say one size fits all. We say that we go in each case and workshop and find out this is the best practice, is find out for that plant, what are their most urgent operational optimization needs. So it's a really good question.
Yeah.
All right. This is going to have to probably be the last question because we're going to wrap it up and we're running out of time. Can Lumada software use AWS Cloud, or it is only exclusive or compatible with Hitachi Vantara for storage?
Nope. It is compatible with all major cloud vendors and can run either in the public cloud, in your private cloud, or on-premise, or a hybrid.
You don't have any more to add to that? I mean, that was pretty quick.
No, you said it exactly right.
Wow. Excellent. Well, we have one, and Mafi said thank you. So he said thank you, or she's, I don't know. And one last, we got it, because you guys were so quick on that last one, we can put in one more. What is the best way of correlating time series OT data with IT data so that you have full contextualized data to work with. Woo!
I have an example. John, you want to go for it?
Very good.
Well, yeah, so this is one we grapple with all the time, is synchronizing timestamps. So time series data is obviously time series data. So it's all, the x-axis is time. The IT data doesn't necessarily, it may have timestamps. So for instance, a part that's scheduled on a certain line or certain machine, but that's not the actual time. So we have retrofitted, we've created some situations where we can retrofit machines to be able to scan a barcode or an RFID to know exactly what the timestamp was. And that's how those things get correlated. So it's tricky and it's different in every case. But Shamik, go ahead.
I was wondering whether I misunderstood the question. Was it about trying to figure out the advantages of what happens when IT and OT data has been contextualized?
No, I'm just the conduit of this
Can you read it
information.
again?
You're going to have to figure this. Come on.
Read it again, please.
All right. What is the best way to of correlating time series OT data with IT data so that you can have a fully contextualized data to work with?
Oh, that John answered that. No worries. I was actually going to talk about.
You just wanted to just jump in and say, hey.
No, I thought I heard what do you get when you try to merge the two and contextualize it?
Okay.
Then I've got hundreds of examples.
All right, we do have additional questions, and hopefully, we'll be able to get back to you with answers. That's the commitment of IIoT World. They will do that. So thank you very much, everyone, for a great job in participating. And the questions were just fantastic. Now, again, we're going to have Lucian Boom do a real-time giveaway of books. So Lucian, take it away.
And thank you, John and Shamik, for a very engaging session. Really appreciate it's late in the evening here. Appreciate the audience for hanging around. We had throughout the day about 265 questions in the Q&A, so unique people that asked the questions. So in addition to the fact that we're going to invite everybody in our VIP community, which basically had preview to early on the events, what we'd like to do next is switch over to 5 of those 265 will be receiving a book from Rebecca Morgan. She was one of the authors early today. So we're going to buy 5 books and send them to these 5 winners. So what we did, we exported from the Q&A of each session. We had 10 of them through today. There were about 5,800 people registered throughout the day. So thank you for making a record number for the manufacturing day. Stay tuned for next session, which is May 12th. So I'm going to switch over to basically do the wheel of names. The wheel of names will have basically, we're going to spin the 5 times and we get 5 winners. So let me switch over to the website. Let's see what's the best way to do that. Just share screen. So I apologize if that, here we go. Hopefully you see the spinning. Scott, can you confirm that?
Nike. Yeah, looks great.
All right. So basically all of them had been exported, imported in this. So you should see some of the names that had asked question at the end added here. So appreciate that. So the first winner, let's do that. All right. You don't need to be present to this. So Trip Braden.
That's pretty cool.
Right, so Tip Braden will be receiving the book from Rebecca Morgan on manufacturing. It was published in September. So let's remove that. And my team will record his name and get that. So let's do that one more time. Don Lovett. Don Lovett will be receiving the book from Rebecca Morgan on manufacturing. Madhu Gaganan, thank you for supporting us. Thank you for being active. And we got 2 more winners, I believe. Now, Christoph Bujak, thank you for asking questions.
See,
And
how
here
do
we
you
go.
read those names? How I could never get close to those names.
I'm just sounding confident, Scott. I'm not sure I'm pronouncing it properly. Not to laugh, but it's like you're saying. Appreciate you being honest.
I
Patrick,
can read that name.
I think that's an easy one. Thank you, Patrick.
Yeah.
And thank you all. It's been a long day, but it's been a very interesting day from challenging the status quo of some of the existing tool, disrupting the markets, IT OT convergence. We wrapped up with this. I've learned quite a big deal. I'm gonna have to go back to some of them, even though I listened to all of them. So appreciate it. See you on May 12th. That's the next digital or manufacturing day from IoT World. Appreciate the sponsor of this session, Hitachi Ventura. Appreciate everybody, Scott, John, Shamik, and all the speakers today that made this a successful day. Have a great rest
Thank
of
you
the
for
day.
having us.
Good job.
Cheers.
Thanks, Scott.